Go with Brianna. Excellent. Now, when I look at that, thinking back to what I wanted to do before, can I rewrite 5 and 4 using the same base? I mean, technically I could figure it out and get a little crazy with the calculator, but no. The answer is no, thinking about what we did in the previous micro lecture. All right? And what do you notice about the variables? Where are the variables? They're in the exponent. So in order to get them out of there, I need to take the log of both sides. All right, so that's the first step, is to take the log of both sides. Now, why would I do that? Why would I take the log of both sides? I used a base of 10. You can use whatever base you want. I use the log of base of 10 because that's what your calculator can do. But why would I take the log of both sides? What does that help me do now? Why? To be on the floor. It's the first time I've ever heard them say that. Yeah, they're up in the ceiling, I guess. Yes, we want to get them on the same floor. Do you know what property that's called? Close. There's a different word we used.
Exponential.
There it is, Sylvester. The power property. But Emmanuel is right. It allows us to get them on the same floor. I like that, Emmanuel. I'm going to use that and not give you credit, okay? Thanks, man. Appreciate that. All right. Look at the left side. What students usually struggle with when they look at these problems is they see the logs and they kind of freak out with logs. All right, but the log of 5 is just a number. The log of 5 is just a number. So imagine it was 5. All right, just for a second. Imagine this was just a 5. What would you do to distribute that left side if it was just a 5? What would you write? Very good. So I'm going to do that, but it's not just 5. I'm going to write x times the log of 5 plus 2 times the log of 5. Okay, I'm going to pause here. Raise your hand, ask a question if you're confused about what is happening right now. Everybody feel okay about that? Now, look at both sides of the equation. On this side, I have x times the log of 5, and on this side, I have x times the log of 4. I would like to get those logs to be together. All right, so which way do you want to move them? I don't care. Let's go to the other side? Okay, cool. So I'm going to write down minus x log of 5 on both sides. All right, now watch how that works. So on this side, I have 2 log of 5 equals x log of 4 minus x log of 5.
That's why did you teach us like that?
Something about that. Okay, everybody still feel all right? We're almost there. Keep pushing. We're almost there. Look at the right side now, because Sylvester decided we're going to move it to the right. If you'd done the left, it didn't matter. Do you see how on the right side we have 2 terms? What do they have in common? What do they have in common? They have x. So I'm going to factor out x, and what does that leave me in the parentheses? Perfect. Because again, I know, even though it says log 4 minus log 5, you think, oh, that's a lot of stuff. But it's actually just a number. All right, finish it for us. Who wants to finish it? How are we going to finish it? Say it again? No, because what do I want to isolate? What am I trying to get by itself, Yesenia? I made a little mess up there. I just want an x, right? So Galileo, what am I doing? From both sides. Very good. So I'm going to divide log 4 minus log 5 on both sides. So on the right side, it's just x. All right, so our answer with logs is going to be 2 log 5 over log 4 minus log 5. Woo-hoo-hoo, man, that was fun. No one agreed. All right. Okay, let's have everyone that's calculator on the desk, give me this as a decimal. So in your calculator right now, use the n over d function and do 2 log 5 over log 4 minus log 5. I would highly recommend a yellow calculator, Andriana. The phone is a lot tougher with the logs. I got a number over here. What is it? Negative 14.425. Let's get someone to confirm. Yes? Okay, so x is approximately negative 14.425. I got one confirmation. Can I get a second one? Got a third one. Excellent. Okay, so what does that mean? I'm going to plug in on the left side if I check this. So I've got 5 to what power? 5 to what power? Okay. And what about on the right side? All right. Type those in, see if you get the same thing. Might not be exactly the same because we rounded. We're approximating. We're looking for roughly the same numbers. Okay? You basically, Edgar back here basically got 0.2. Look at that. I just watched Edgar do it. He got the same thing. Well done, Edgar. Was there a question, Jalissa? Sorry. Oh, my remix? Yeah. No. Does everyone see what to do when you don't have the ability to rewrite both sides with the same base? Process much longer, more complicated, but you can do it if you focus on logs and your understanding of the properties. All right, let's move to log equations. Now we're going to move to solving logarithmic equations. Find some area above this slide or around this slide. I want you to write down 2 things. All right, I want you to write down 2 things. Number 1, so you're writing this around example 4. Number 1, 1 log on one side. 1 log on one side. That's goal number 1. Getting 1 log on one side. If you can do that, you'll find success with these logarithmic equations. Goal number 2. 1 log on each side. We're writing this around example 4, Jalissa. Somewhere around there. If you can get 1 log on each side, you will also have success on logarithmic equations. All right, so just say that to yourself a few times. All right, here we go. Example 4, read it for us, Jace. And so you're asking for the first part? Someone help Jace to the very beginning of it. How would you start it? Log base 2 is how you start. Go for it.
Log base 2.
Perfect.
Plus log base 2, 3x minus 5.
Okay. Perfect, Jace. Thank you. Number 1. 1 log on one side. Is that happening here? 1 log on one side. Is that happening here? No, because we have 2 logs on one side. So goal number 1 has not happened yet. Goal number 2, 1 log on each side. Goal number 2, not happening either. So that means we need to use some log properties to manipulate this problem. Jace just read for us log base 2 of 2 plus log base 2 of 3x minus 5. When I see addition of two logs of the same base, I think what? Multiplication. So let's have the log base 2. Yesenia, what are you going to write for the new argument? She doesn't know. Who knows? What's the new argument? Yes, Susanna?
2.
Awesome. And could you do that for us in your head? She said multiply 2 and 3x minus 5. Excellent. Thank you. You see it? You said it? Okay. Equals 3. Uh-oh! We have just achieved what? This is goal number what? 1. We have just achieved goal number 1. 1 log on one side, which means it's time to solve this puppy. Who's got it? Where do we go now, Jalen? You got this, Jalen. Come on, Jalen. What now? Give me some of that. Plus 10. No, Jalen. Swoop it for me. Swoop it up. Come on, Jalen. You can do this. Come on, Jalen. Come on. Change it to be an exponential equation. Do it for me. You can do this.
Oh my God.
You're gonna make it. You're gonna make it. Just breathe in and out. Yeah. Start at the base. What's the base? What's the base? 2. 2 to the. 2 to the what? 2 to the. All right. Just clicked in Jalen's brain. Give it to me, Jalen. Yeah, Jalen. 2 to the third power equals. I love it. Like what?
Like
Legendary.
Legendary. Wow. Hashtag legend. Man, that's a lot to live up to. Okay. 2 cubed equals 6x minus 10. Does everyone see how we did that next step? That is called changing it. Mathematically you would say, changing it from logarithmic to exponential. That's super boring, so that's why I said swoop it up. Okay? So, what's 2 cubed? 8. All right? Move that minus 10 over, Jalen. Now you can do it, now that we've swooped, by adding 10. So what do you get on that side, Jalen? 18. So, Jalen, hit me with the answer. Excellent. Do we know it's right? Let's check. I love it. Okay. Nothing happening here, right? There's no variable. So that's just going to be log base 2 of 2. We're good there. Plus, what's going to go next if I plug in my answer of 3? What'd you do, Susanna? Which is, I think we can do this in our brain. Log base 2 of 2, ask yourself, 2 to what power gives you 2? 2 to what power gives you 2? 1. 2 to what power gives you 4? So what's 1 plus 2? 3. Is that what I wanted? Yes, it is. So it works. The answer is 3. Not just coincidence, there are so many 3s in there, but the answer is 3. Questions on example 4? We got one more. One more to go. All right, last one. Let's do it. Last one. Yes, of course. Which slide? This slide? This one. Example 4. All right. Example 5, our last example. Read this one for us. Let's see. Andrea. Excellent. Now you'll notice there were no bases. So what are the bases for all of these? They're all 10 because they're called what up? Common logarithms. Learning something. Step 1, or excuse me, goal 1. 1 log on one side. No, there are 3 logs. Way too many. Goal 2, 1 log on each side. We've got it here, but do we have it over here? No, but Andriana read for us 2 logs connected by subtraction. So you want to think division. So we have the log. Okay, Yesenia, your second try. What's going to be the new argument when I smash them together?
Do you put it in like a fraction, or do you?
That sounds good. Division is fractions are division.
3x minus 2.
Yeah, damn, what's it? Over 2. I love it. Damn, I'll grab the notes on your way. And we're recording, so don't worry. I'm sorry I interrupted you, Senia. Thank you. That is correct. The log of 3x minus 2 over 2 equals the log of x plus 4. We have achieved what goal? The second goal. 1 log on each side. 1 log on each side. Once you do that, all you care about are the arguments. 3x minus 2 over 2 equals x plus 4. Now it becomes early high school. Yes. All right, what should we do next? Move the 2 over with multiplication. Sounds good to me. So on the left side, we have 3x minus 2 equals. All right. Next, Susanna, what would you do? Okay, you want to move the 2x? Sounds good to me. Just crushing this algebra. So that's going to be x minus 2 equals 8. You're already ahead of me. And then what? X equals 10. I love it. Let's see if that is right. Well, give me this first one. X is 10. What's that first one if x is 10? What is it? 28? Okay. Minus. Is there any x in that one? No. So I need to get what that is. And then what's on the other side? Okay. So who's going to do log of 28 minus log of 2? Who's got that? Oh, Susanna's got it. Hold on to your number. Who's going to give us the log of 14? Who can give us the log of 14? Susanna. Can't do it all, Susanna. You can. Who's going to give us the log of 14? Who's got it? You got it. Okay, on 3, say your numbers. 1, 2, 3. Yay! Excellent. X is 10. Questions? Because you're about to get up and try. Now, because we only have 15 minutes, and these are longer problems, we're going to spend the whole 15 minutes working on these at our spots. Tomorrow morning when you arrive, we're going to do the exit ticket. All right, so it'll be an entrance ticket. Questions? All right, let's spend the next 15 minutes trying these. Go!